Hello. Okay. All right, here we go. So move this up here, just so you know I'm here. It's me. Okay. So starting on these notes. By the way, I guess we would call this Unit 9. All right, right? Wasn't it Unit 8? I called the last one the eighth one. I believe it was. So, but back in the day, this was in our Chapter 13 Algebra 2 book. What's Algebra 2? Um, but anyway, now do this so you can kind of see that projected in the screen. All right, so we're in rows because this is just really, you better focus. I mean, this is what we're going to do today. These notes are the backbone of what we've done for 2+ months in CAT right now. It's so important. If you get this down, this next unit should be pretty not too bad. Next week we have a 4-day week, right? And then you have a 4-day weekend, right? Right. Then we come back Tuesday, and then the quiz on this will be Wednesday. That's what the powers that be decided. Go ahead and throw it on my chair. So, and that's kind of spread out and a little bit lengthier than I'd like it. That means we're going to do a little bit more than we did last year, I think. And I'm going to hold you a little bit more accountable for a couple things. This is a key, though. And by the way, do I use A, and A root 2, or what number do I pick for A? 3, 2, 1, go. 1. So you really could have wrote 1, 1, 1 root 2, and then 1, 1 root 3, 2 times 1, 2. But it doesn't matter. Maybe keep the A's for right now, and then we're going to move on. And then I'll give you my argument for this next thing because I've taught CAT for years, meow. And oftentimes in the middle of CAT, the students are like, why are we doing this? What is the point of this? What's actually called um, coordinate trigonometry or coordinate plane trigonometry, throwing angles into a coordinate plane. Well, by golly, the Earth has been put in a coordinate plane. You know what the two things that make up the coordinate plane of Earth are? They start with L's. 3, 2, 1, go. Longitude and latitude. I'll give you an interesting bit of information I looked up about 4 or 5 years ago because I was curious. We actually do some Earth questions in CAD. We will not, but I found out that okay, so here's 1 degree. 1 degree is very small. Boink, right? Just one little degree, right? Very small measure. Just shake your head. Yes. So you can actually cut a degree into 60 equal parts. 60? Why would that be 60? How many minutes are there in an hour? 3, 2, 1, go. 60. So they cut degrees up the same way that they cut time. And then I found this interesting. This is amazing. 1 minute of latitude. I mean, 1 degree on Earth spans many miles, but 1 minute actually equals 1 nautical mile. How many people have heard of 1 nautical mile? Raise your hand. Okay, what do you know about a nautical mile? Is it bigger than a regular mile, equal, or smaller? 3, 2, 1, go. It's slightly bigger, all right, but it's close to a regular mile. So that's why they call it a nautical mile. And I found that interesting. So 1 minute, and then you know what? They actually cut minutes into seconds as well. So now you have 1 degree that can actually be cut into really 3,600 parts. Cut it into seconds because there's 3,600 seconds in an hour. And now you can really pinpoint a position on Earth globally by breaking down latitude and longitude into degrees and also minutes and also seconds. And then I actually calculated it 1 year within how many feet when you give that measurement in degrees, minutes, and seconds, and it's very, very close. Like at that point, you could see like if an object is at this position, you would see it. It would be that close to you. So anyway, giving you that idea, its location. So when you're an engineer always puts something on a paper first or in a computer in a document before we actually go to production. So where things are in location to each other is very important. All right. So that's why a lot of times they coordinatize a situation. So where things are relative to each other are spot on. All right. So anyway, that's the argument for a coordinate plane. All right. And it's huge. Like I say, for 2 months, that's all we've been doing in CAT. All right. And then I'll complain about my CAT students again, who are the charlatans that don't do their homework. And I swear to dog, if you're still hanging on to that idea that I don't have to do daily homework, you're going to be destroyed in this section. So those that still have not decided to do their homework, you better change. Otherwise, an F is coming. All right. Believe me, I've taught this long enough where it's not hard. It's just you need this rote, practice every single day to get things solidified. Okay, so done with the speech. Let's do the math. Okay, here is what standard position is. Okay, it is putting an angle in a coordinate plane. By the way, I'm going to point randomly to a position. You tell me what quadrant this is. 3, 2, 1, go. This one. What quadrant is that? 3, 2, 1, go. 3. Okay, I just picked a random spot. But in math, this is weird, and you're going to see this happen twice. This way, I think I've said this before because we've talked about the coordinate plane. In math, normal direction seems to be counterclockwise because when I number in order the quadrants, I have to go counterclockwise to go in order. And that's going to happen here again today with another new concept. But here's when we put an angle in a coordinate plane. The initial side is always the positive. Get your highlighters out. Positive x-axis. So maybe highlight initial side that word and then highlight the positive x-axis there. Your angles will always start there. We just need a starting point. We need, what's that called? For everyone to do the same thing right. So someone decided, hey, let's make it that. And then everyone agrees and everyone does it. Terminal. What's initial mean, by the way? Starts with an S. ST. Yeah, start. Reason I want to put that is what's terminal mean then? 3, 2, 1, go. End. So ending side can land anywhere. There's nothing special about this. I think in first hour I said it's the second side that makes, you need two sides to make an angle. We know that. So terminal means end. I guess I'm gonna put that there, and then when I do a terminal side in my coordinate plane, we'll highlight it with a blue. Okay, so what's standard position? This, when your initial side is the positive x-axis and your angle lands, your second side lands anywhere. All right, I don't know what else to really say about it. We don't really need to formally define it. So an angle in standard position. Oh, I have to start at the positive x-axis, and then whichever direction I go. All right, you go ahead and read this real quick. I'll give you like a second, maybe like 5 seconds. And then we're going to go back up to our drawing. And those in the movie, you can watch this and read it. Did you read? All I see is you looking up here. Are you reading up here? Okay. All right. So should be a quick read. Let's do a terminal side just like in the other hour here. Okay. And then I'm going to go in this direction. So what kind of measure is that? Positive or negative from the reading down there? 3, 2, 1, go. Positive. That's all you have to do is read, and there is no confusion on it. This is what it is. By the way, what would be a good possible angle measure for that? 1 something, all right, between 90 and 180. So I would say about I'm just going to make it 125. We could get a protractor and measure it, and then look at the protractor. I used to have a big teacher protractor. I could actually literally measure that on the screen. I don't know what I did with that. That is curious. I think I lent it out to someone and they stole it from me, now that I think about it. All right. But anyway, when we go in a positive direction, again, here's the second time in math where counterclockwise seems to be the norm. I think positive normal, negative abnormal, or positive good, negative different bad. I don't know. Just the way my mind works. So I'm going to highlight this in blue. That's just a random angle with a random terminal side. So now that's what terminal side means. Okay, and then I could also have this, but then I'm going to go this way. Okay, from the reading, what kind of angle is that? Positive or negative? 3, 2, 1, go. Negative. And then I made it a bigger opening, but it's still not up to 180. So a good maybe negative 170. I forgot that one. That was not my pen. That was my brain. All right. So negative 170 degrees. So there's our first thing of the day. All right. Negative angle measures just mean direction. All right. So negative 170 and lands in quadrant 3. So we did all that reading. And then that's weird. So I guess I didn't highlight those, but I could highlight this in green. The key components here. Counterclockwise is positive. Clockwise means negative angle measures. That's it. Okay, that's it. That's all that happens. Okay, next. All right, now you want to get nuts? Let's get nuts. This I probably could have done this after. You know what? I'm going to skip this. That is a good idea. Thanks, Danny. All right, Mr. Samulus. Yes, he's talking to himself. We probably should do these first. Okay. All right. Let's get our group responses ready. Otherwise, I'll start calling. Remember when I had the calculator out and I call you by your number? Don't make me do that. Where's negative 15 degrees land? Quadrants 1, 2, 3, or 4? 3, 2, 1, go. 4. Okay. It's just a little clip right here. Yeah. Little, like just a little maneuver right there. And there's negative 15 degrees. Now look at what the words in the directions are. Find co. What's co mean in English? Starts with it's many words, but let's use a word that starts with S. SA. Come on, what's SA? Co means same. And then what does terminal mean? If I could speak, ending, same ending side, ending side. Oh, my blood's starting to boil with thinking about my cat suits. But I'll wait. I'll complain about those later when we get in deep in the notes and how 2 months later they still can't do these things correctly. All right, and that's what I mean about the non-homework doers. It's going to be you're going to be keep doing the same thing over and over again if you do your homework, and it's just going to solidify. Those that don't do their homework, though, in my cat class, are continuing to fail, and it's a snowball effect. They just won't do it, and then those that are doing it, the class is very easy. Those that are not, it's snowballing in the opposite direction. Right. So I can't emphasize how important this is, what we're doing here. So here's one coterminal, and I think you're going to find this pretty easy. What if I decided to go in that direction? Then what does that measure? Because it lands in the same spot, lands on the same side. What does that angle measure? I think we could figure that out. 3, 2, 1, go. Blah, blah, blah. 3, 2, 1, go. 345, and it's positive. Now I want you to think about illegal activities in Walmart's parking lot. When it snows, if we didn't have such global warming, did it really snow this year? I feel like the shovel came out once. But when we used to get snow 10 years ago, what would you do in Walmart's parking lot illegally? You'd do what? Donuts. Okay. And what happens if you do a donut and you end right back where you started? I'm going to choke myself on this wire, so I can't really show that. What did you actually do? Three. So everyone knows what 360 means. So in Walmart's parking lot, we have a boring person. Oh, okay. And then we have, well, I'm going to go this way. And we go, and then when I look at the cars, am I going to know the difference? Yes or no? No, they're facing in the same direction. And that's what we need to think about when we're doing this. Then wait till I show you the next ones when we have these. All right. So facing the same direction, but a different way of getting there. That's what's going to happen with these angles. As a Federmact, there is exactly how many different ways we can name this terminal side. The number starts with an I. 3, 2, 1, go. Infinite. There's an infinite amount of ways I can name this angle measure and still land here. Because all I would have to do with these two angle measures is keep adding or subtracting what number, which I already said before. 3, 2, 1, go. 360. So that tells me the next one. Well, let's draw negative 700. Negative 700 is negative 360, and then I got to do some calculating. Negative 660 is another negative 300. I got it. It's negative 340. So after I draw that, what quadrant does negative 700 land in? 1, 2, 3, or 4? 3, 2, 1, go. 1. Not 4. 4 would be the only acceptable bad answer. I don't know why we would say 2 or 3, but you got to go clockwise. So here's 360 negative, and that's how I show that. And then here's another negative 340, which lands almost another rotation, but lands there. And this is easy. What is this angle measure right here? What is that angle measure? 3, 2, 1, go. 20. If you can't get that, we got a problem because all we're doing is we're 20 short of a 360. So that is coterminal and it follows my directions between 0 and 360. That's an angle that lands in the same spot. So this person had a lot of fun. Whee! Bang. This person, I'm just going, all right, I'm done. But we're facing in the same direction. So we have a similar ending point. All right, 360 plus. This is easy. 300. Where does this land? What quadrant? 3, 2, 1, go. Oh, okay. So here's 360. And then how far did I go right now, which we're doing in the future anyway? How far did I go right there? No. How far did I go right there? That second one I just marked. 90. Then how far did I go right here now? 180. And then how far did I go right now? So that's why we should have got quadrant 4 right away. It's 90, 180, 270, 360, 300 lands right there. Okay, so I already have the answer. What's the answer? A coterminal angle measure that lands in the same spot. Here, I'll help you. Let's just erase that first little rotation. What's the answer? 3, 2, 1, go. Oh. 300 is the angle measure between 0 and 360 that lands in the same spot as 660. Okay, so that's what those directions, or satisfying those directions. Heard someone say a negative 60. That's for our next set of examples. That doesn't fall between 0 and 360. So read your directions, follow the directions. All right, and then you'll be good. Now, what we just said for that last answer works for these. Find one positive and one negative angle that are coterminal with the given angle. First of all, where does 141 land? 1, 2, 3, or 4? 3, 2, 1, go. 2. We only have 2 people answering. Not sure why. Oh, I should get the calculator out and start picking on individuals. All right. Quadrant 2, because it's past 90, but not quite 180. All right. And we're always starting here. That's the beginning of the notes. All right. That's what's got to happen. Okay. So what's this angle measure? Maybe I'll color code these. I need to find one positive. I'm going to go positive. Whoa. And then that. What's the math in order to find that green angle measure? Add what to 141? 3, 2, 1, go. 360. So 360 plus 141 is 460. 501. Do I have that right? Right? A lot more fun in Walmart's parking lots. So that's why we should understand that. Oh, and then here's the other one. Blue doesn't maybe show up so big a difference. That one. So that is my negative angle measure, negative angle. And what is it compared to 141? What do we have to subtract from 141 legitimately? 3, 2, 1, go. 360 again, because the blue and the red add up to 360. So that's the difference between the two. What is that? Did anyone get that already? Negative. I'm always by myself. Is it negative 219? Okay. Negative 219 is the blue. They all land in the same direction. Okay. Some are just different than others as far as how you circularly got there. Okay. Next one. Negative 289. What quadrant does that land in? 1, 2, 3, or 4? 3, 2, 1, go. 1. Because you have to go clockwise. Clockwise 270, 289. So that's where the angle lands, where the side lands, the terminal side lands. Okay, again, initial side always the positive x-axis. So what's this little sliver right here? What's that? 3, 2, come on, 1, 0, 71. So this one's 71. And then the other negative is going in this direction, that, and then that. Or you could do it like 5 times and it would still be the right. Don't do that though. That'd be annoying to grade. All right, but add negative 360 to that. I don't know. 560, 660 minus 11, negative 649. Does that sound right? I love trying to do mental math. I think I need those brain exercises as I get older. All right. And then 540. Oh, 540 is 360. By the way, one of the answers is going to come up here right away. Plus 440, 330, 240. Is that 180? I don't think I did this one. I think I skipped this one. Okay, so what's the positive coterminal angle that lands in the same spot as this? So what is this angle measure from here to here? 3, 2, 1, go. 180. It's right there. I already lopped off that 360. Oh, and then by the way, what was I doing negative in? What's this angle measure from here to here? Negative 180. Okay, and that satisfies those directions. Okay, now you want to get nuts? Let's get nuts. Now let's go back up to this. This is huge. And actually, my CAT students, I think, are doing better than those in the past. But I still have those latching on people that are just, a month behind and still don't get what we're going to do right here. By the way, what we're going to do is put all the angle measures that are important, that are, and allow us to do exact trig answers. And exact goes back to the engineering idea. A lot of engineering, you need exact values inputted into the computer so it makes the objects and they fit together, and then you can produce a product and actually send it out to the public. So exact is huge in that respect, and not just engineering, many different fields. So we're going to only name the positive angle measures. So we're only going to go counterclockwise. And we're going to start with what's called, I'm going to throw out a word that'll be used later. These are called the quadrantals. Hey, everyone, what's that angle measure? 3, 2, 1, go. 90. Hey, everyone, what's this angle measure? 3, 2, 1, go. 180. What's the third one? 3, 2, 1, go. 270. And then I do a full circle. What do I get? 360. So that's what we're going to start with, and I'm going to erase this. I'm going to throw some things in here. You decide if you want to or not, because it really leaks into the last part of the notes. All right. Now the 3 in each quadrant, I am going to color code them. So if you have colors, it might be smart to do this. Okay, color coding these. I'm going to stick maybe with red because I have red, blue, and green, even though blue and green. So I'm going to start with red. This first angle measure is actually 30 degrees. Why would that be? Well, it's this very first one. I'm going to draw what's called a reference triangle. Okay. And this is why this is important. All right. So I'm going to zoom in on this. We don't want to do this too much because it's going to jack up our picture a little bit. But each quadrant, I'm going to draw at least 3 of them. This is a coordinate. What coordinate is listed first, by the way? I accidentally drew something there I didn't want to. Which coordinate's listed first? 3, 2, 1, go. X. So this is how you draw a reference triangle, and this is going to be a coordinate. Okay, so we're going to put this right here, a coordinate, because this is what this is called. It's called coordinate trig because you're in a coordinate plane. So that point right there, that point can be made as a triangle. And this is how you always do it. And I swear to gosh, I want to throw my computer. I still have CAT students that do the triangle wrong. Which coordinates listed first, everyone? X. So this is literally how you do it. X, Y, and then you go back to the origin. Bang. And that's how you draw your triangle always. If your triangle is ever drawn to the y-axis, I should kick you out of the class. Gone. You're gone. And some CAT students should be jettisoned out of my class because they still do it. X, comma, Y, back to the origin. All right. Now, this is a 30. Here we go. What's the side opposite the 30? 3, 2, 1, go. Or 1. Okay, this is what I had my CAT students do. And then what's the side opposite the 60, which is this? 3, 2, 1, go. Root 3. And then what's the side opposite the 90? 3, 2, 1, go. Now, there is a little problem with this, but I'm going to leave it. I'm not going to say anything more. This is what we can do in order to do trig now on this triangle. We got our sides, and now we can find exact values of sine, cosine, and tangent of 30 degrees using these as the side measures. And yes, this is the opposite side. Yes, this is the adjacent side. And yes, this is the hypotenuse. And then the coordinate is literally root 3 comma 1. That's where it exists in the coordinate plane. Now, something different occurs later when we deal with really what's called the unit circle, but we're at the beginning stages of this. All right, what do you think the next one is that's an important angle measure? 45. And then what do you think the next one is? 60. And that creates a 60, 30, 90, but the 60 is the reference angle. And I want you to highlight that too, the word reference angle. That is the one, the angle attached to the origin. All right, that's the reference angle that dictates opposite, adjacent, hypotenuse. I really hope you are looking at this going, this looks reasonable. I don't think this is anything much of a challenge. I don't know what happens with my CAT students. I don't know why we can't get this figured out. It's almost a choice to just not do the homework and not just do what we need to do. Hey, if this is 60 this way, then how much is it from this way? 3, 2, 1, go. He's the only one? Okay, I'll draw that. I need this angle measure next, which is 60 degrees away from that. Look at that and look at that. And then everyone tell me what this angle measure is. 3, 2, 1, go. 120. Should not be a problem. We should have said that out loud. And it is green. So what I'm saying is 120 degrees actually creates, let's draw that triangle, wait, hold on. X, Y, and then back to the origin, which is the hypotenuse, creates a 60, 30, 90, where 60 is the reference angle. And again, we don't want to do this too much because it's going to slopify our unit circle here and why we're doing what we're doing. By the way, what's the side opposite to 30? What number is the side opposite 30? 3, 2, 1, go. This is not going well. 1. What's the side opposite to 60? 3, 2, 1, go. Root 3. What's the side opposite to 90? 2. And then, wait a minute, something's wrong. This is a coordinate. So that coordinate is I went left and up. When I go left, what kind of number is that for X? 3, 2, 1, go. Negative. Now we're getting into it. This is what happens with coordinate trig. All right. We're going to get negative sides weirdly. Negative sides. And then that's another thing that my CAT students ignore. The whole point of this, the whole idea is you get negative coordinates sometimes in different quadrants, and that they just ignore the negatives. Oh, it's so mind blowing. The mistakes that are made, and just not taking care into what the new thing is. And this is really the only new thing. Oh, I have coordinate trig, so I got to be aware that these are coordinates in a coordinate plane. Right? That's the next angle measure. What's 45 away from 180? 3, 2, 1, go. 1. I'm going to throw a podium. Okay, what's 45 away from 180? Subtract the 2. 3, 2, 1, go. 135. And if you can't get this next one, blah. What's 30 degrees away from 180? 3, 2, 1, go. 150. There you go. And it feels good to answer questions instead of sitting there like a blob. Hey, what's 30 degrees past 180? 3, 2, 1, go. I'm going to do that fast because that's easy. If you can't add 30 and 180, we got a problem. Okay, take a second for 45 past 180. 3, 2, 1, go. 225. You know what? Let's spend a minute. This is going to be weird. This is why things don't match up. This is actually called a unit circle, where technically, not technically exactly, the hypotenuse is 1 instead of 2. So this is why this next thing is going to be weird. But I'm going to go ahead and draw the blue triangle. Draw the blue triangle. So here we go. X, Y, back to the origin. This is why these aren't going to match up. But what are the side measures for a 45, 45, 90? What are the first two? 1. Wait a minute. This green one was 1. How come they're not the same length? Because I didn't get the radii to be equal. So there's a little difference here. By the way, what kind of 1 goes left? Negative. And then what's this one going down? Negative. And then what's the hypotenuse? Root 2. Because this coordinate right here is technically -1 to get in quadrant 3. All right, now again, the radii equaling 1, we'll tackle that later. Right, and that's why the blue and the green sides are not equal actually on the paper. All right, so that's a 45 in there, and that's what we're going to be doing later. 60 past 180. What's this angle measure right here? 2, 3, 2, 1, go. 240. Now, 60 short of 360 is what? 3, 2, 1, go. 300. That's easy. 45. I'm trying to grab my correct color to keep this. I'm not sure I use the same colors in the other hour. But what's 45 short of? You on your okay? What's 45 short of? 3, 2, 1, go. 315. That one sometimes the 45 sometimes we're a little bit off on. My cat students are. And then what's 30 short of 360? 330. Heard a different answer there. Okay. So why is 315 a 45? Because it's 45 short of 360. When I draw the triangle X, Y, R, sorry about saying R, X comma Y, and then go back to the origin, that angular difference is 45 in there. Okay, so say hello to your, what actually is called the unit circle, but it's not yet because I didn't show you making the hypotenuse is 1 yet. Hypoteni, maybe that's the plural of hypotenuse. Who knows? Okay, and then this is why I did this. Now it's time to look at your homework. Let me have your homework sheet. Okay, on your homework sheet, are you doing that on purpose? I'm going to throw out my back. All right, so the first 3 are exactly like I'm going to show you, but then when we go to this side, I stopped with the, this thing here. You draw your own little coordinate plane, see where the triangle lands, label your sides, and then do the trig. So just without this thing given here. All right, so where does 240 land? And I don't know why we're not doing tangent. I'm going to go ahead and do tangent as well. Where's 240 land? What quadrant? 1, 2, 3, 4. 3, 2, 1, go. 3, because here it is. And then really to know that it's this one, that's 240. That's 240 degrees. Okay, but then to make your triangle, maybe I'll go dark. No, black won't work. I don't think. Maybe I'll do dark green here. To do this triangle is X, Y, R. And again, I'm going to get the red pen of vengeance so bad. Anybody that does a triangle going to the y-axis. It is an absolute aberration to what coordinates are. It's X first, then it's Y. All our triangles are connected to the x-axis. Every single one. So those that do that, I can't. I just don't get it. I don't understand how that could even be possible. All right, what's the 30-degree side? 3, 2, 1, go. What number should I put there? 3, 2, 1, go. 1. What number should I put after across 60? 3, 2, 1, go. And again, this is the cat students that still can't do these sides. I want to kick them out of my class. 2 months of talking about this, and they still can't label these sides correctly. You're going to see if you actually do your homework, these are going to be repetitive over and over and over again. And only the true charlatan that doesn't do their homework correctly either doesn't do it or copies it, never gets this figured out, never gets these sides associated correctly. And as a teacher, I have no answer other than you're fooling yourself. You are doing something completely and totally wrong. And if you get this figured out, this next week's going to be super easy. All right. Oh, I did a mistake though. I went left and I went down. So what's this 1? 3, 2, 1, go. Negative. And what's this root 3? 3, 2, 1, go. Negative. That's the difference, between coordinate trig and regular trig in geometry. We can have negative side measures on triangles. All right, so that's what I did. I located the terminal side. I made the reference triangle and noted the reference angle. I labeled the sides, and now it's SOHCAHTOA. And I will do tangent as well. So what sine? You're doing sine of 240, but you're really doing sine of this angle measure. You're doing that sine of that 60 in quadrant 3. And then this is the opposite side. This is the adjacent side. Whoop, I was going in the wrong spot there. And this is the hypotenuse. Okay. All right. So what's sine of 240? Negative root 3 over 2. I guess we just have a color change. Cosine of 240, no time to change it back. Cosine is adjacent over a hypotenuse, negative 1/2. Didn't say that up in the directions, but we're going to go ahead and do tan. Tan of 240, luckily, is negative root 3 over negative 1, which is just root 3. All right? Good, doing good on time. Told you that we didn't really need to be in groups here. This is kind of like your personal focus. Your friends ain't going to help you on this. You need to look at what's going on here. All right, where does negative 225 land? What quadrant? 3, 2, 1, go. It's actually 2 because we went negatively, which means we go in this direction. How far did I go right now? 3, 2, 1, go. Negative 180, right? And then how much further do I have to go? Negative what? 4, 45. This is fun. Third hour is in revolt. I'm not answering your questions. I have rights. You literally draw the coordinate x, comma, y, and then go back to the origin. That's why any fool, he can't call a student that. I will, because any fool that does this deserves the red pen of vengeance. Anyone? Gone. I will so harshly grade that because there is absolutely no reason for it. Okay, now that's a 45. What are the sides opposite 45? I'm done asking the question. If you don't know at this point, you're gone. Hey, to go left, though, what kind of 1 is that? 3, 2, 1, go. To go up, what kind of 1 is that? Positive. You're just answering questions like a robot now. And then what is the opposite of the hypotenuse for a 45, 45, 90? 3, 2, 1, go. Okay, and if anyone's asking, where did that root 2 go? Where are these numbers coming from? There's the door. Because this has already been established. This has already been proven. This has already been used. All right. I know it's only been used a couple times. There is no I don't get it's on this. That is flat out memorization. All right. But it is because 1 squared is 1. 1 squared is 1. 1 plus 1 is 2. Square root of 2. It's the Pythagorean theorem. All right. Did it. SOHCAHTOA. Sine of, and you actually go back to the negative 225. I did write that. It disappeared. So a negative angle measure just is where you land. Doesn't really associate to negative sides. Depending on where you land, though, then the coordinate that dictates if you have a negative side or not. So negative just means which way you go. Now, for this is 1 over root 2. And you always rationalize. And I'm going to tell you, you're going to see, this is why I call those students and cats charlatans. When they don't do their work, they don't write these ratios down that are going to come up over and over and over again. And I find it so sad that I still have some cat students, sine of a 45, they're not writing root 2 over 2. It is proof to me that they have made a decision to do nothing. Proof. And I literally do at some point go, you just need to go. I can't, for you to not know those ratios at this point, you're literally making a purposeful decision to do nothing in my class. Nothing. All right. What's cosine? All right. That's negative 1 over root 2. And this is what I mean. What does negative 1 over root 2 become? I just rationalize it over here. So what does it become? Negative root 2 over 2. I know you're at the beginning stages of this, but you're going to get sick of these ratios. You're going to write them over and over and over again. Every 45, the sine and the cosine is going to be root 2 over 2. Every single time. All right. And that's where my point about the non-homework doers. And hopefully I get the rest of you to actually start making a commitment because it's going to make it better in the long run. Tan of negative 225 is a simple 1 over negative 1. And I did say that in the right way. Every 45, tan of a 45 will be 1 or negative 1, depending on what quadrant it lands in. You're going to get these over and over and over again. Those that do the homework, you're going to be bored by these ratios. And they're going to just come into your head like right away. All right. And that's eventually what we hopefully will end up being. Where's negative 330 land? 3, 2, 1, go. It should be a quick one because you're going clockwise and you almost did a 360 clockwise. So I don't care about colors anymore. So this is 30. So 30, 1, root 3, 2 is what I mean. All 30, 60, 90s deal with the same side. It is literally impossible for me to have a CAT student that still doesn't know these sides. Okay, so sine of negative 330, and all of them are positive because I went right and I went up. And then just one more time, coordinate trig, because that's one of the things we're going to do in the future, Monday or Tuesday. What if I don't have a 30, 60, 90, but I just have random coordinates where the terminal side runs through it? Well, we could still do trig on those and come up with ratios. So sine of negative 330 is 1 over 2. There we go. That same value being written. Cosine of negative 330 is root 3 over 2, another ratio we've written before. And then tan, this one's a little bit annoying. That equals 1 over root 3, which is what? What do you think that ends up being when you rationalize? Well, 1 over root 2 ended up being root 2 over 2. So 1 over root 3 ends up being root 3 over 3. You're going to write this a million times. You shouldn't have to keep writing the rationalization work. Multiply top and bottom by root 3. So that's what I mean when I get mean about the people that don't do their homework. 2 months. I have CAT students that still can't write these ratios down for a 30, a 45, or a 60. All right, so just make sure you make that commitment. 95% of you are there. I'm worried about the 5% and how they can make this a successful section here. Okay, we'll call it a day there.